Let me start with a question. What's the big deal about this repository?
The big deal is that OpenScience is an AI workbench designed to help scientists with their research. It takes a goal and automates the entire research loop, from reading the literature to running experiments and writing up results. It's like having a capable collaborator who can think, act, and report.
That's impressive. So what does it solve for scientists?
It solves the problem of having to manually perform all aspects of research. Scientists often have to read a lot of literature, form hypotheses, write code, run experiments, and analyze results. OpenScience automates most of this, making the process much faster and more efficient. It also integrates with scientific databases and runs experiments on real compute.
What makes this different from other AI tools for research?
One key difference is that OpenScience is model agnostic. It works with any frontier or open-weight model from providers like Anthropic, OpenAI, and Google, using your own API keys. It's also highly extensible, with LSP integration, MCP servers, plugins, and a TypeScript SDK. This means it can be adapted to a wide range of research needs.
Can you explain the concept of the research agent in more detail?
Certainly, the research agent is a single user-facing collaborator that handles the task end-to-end. It loads domain skills when needed and can delegate specific tasks internally. It has different effort levels. Normal and ultra determine how widely it investigates, while plan mode keeps it read-only. This makes it flexible for different research scenarios.
What are some of the bundled skills that come with OpenScience?
There are 295 bundled skills, covering a wide range of areas. These include training with deep speed and PEFT, evaluation, dataset work, molecular and clinical biology, cheminformatics, papers and LaTeX, figures, and cloud compute with tools like Modal and Tinker. These skills make it a powerful tool for various scientific domains.
How does it integrate with scientific databases?
OpenScience integrates with major scientific databases like UniProt, PDB, Ensemble, CHEMBL, PubChem, Archive, OpenAlex, and Semantic Scholar. The agent can query these databases directly, which is a huge advantage for researchers who need access to these resources.
What's the user experience like?
The user experience is through a real workspace in the browser. It includes a file tree, an editor, a terminal, session history, and inline rendering for molecules, structures, genomes, and plots. This makes it easy to navigate and work with your research data.
How does it handle extensibility?
Extensibility is a key feature. OpenScience supports LSP integration, MCP servers, plugins, custom agents and commands, and a TypeScript SDK. This means that users can extend its functionality to meet their specific needs.
What are the installation requirements?
Installation is straightforward with npm, and it runs in your browser without requiring an account or setup wizard. You can use the OpenScience command or npx to get started. For Linux, you need a kernel of 5.1 or newer and glib 2.17 or newer. CentOS 7 is not supported due to its outdated kernel.
What are the limitations or caveats of this tool?
One limitation is that it's still an evolving tool, and while it's powerful, it may not cover every possible research scenario. It also relies on the user's API keys for accessing models, which could be a concern for some users. Additionally, it's designed to be used in a browser, which might have performance implications for some tasks.
What's the future of this project?
The future of OpenScience looks bright. It's an open-source project with active development and a growing community. It's built to do real work in machine learning, biology, physics, and chemistry, and it's likely to expand its capabilities as more scientists and researchers adopt it.
Who should care about this repository?
Anyone involved in scientific research, especially those who are looking for tools to automate parts of their workflow and make research more efficient. It's also of interest to developers and engineers who want to build upon an extensible platform for scientific computing.
What are the key technical or architectural ideas specific to this repository?
One key idea is the use of a single research agent that handles the entire research loop. This is a departure from traditional tools that focus on specific aspects of research. Another idea is the integration of a large number of skills into the workbench, making it a comprehensive tool for various scientific domains.
How does it handle the research process from start to finish?
OpenScience takes a goal and works through the research loop like a capable collaborator. It reads the literature, forms a hypothesis, writes and runs code, runs experiments on real compute, queries scientific databases, and writes up the results. This makes it a powerful tool for scientists who want to streamline their research.
What's the role of the agent in the workbench?
The agent is the central component of the workbench. It's responsible for handling the research task end to end, loading domain skills when needed, and delegating tasks internally. This makes it a flexible and powerful collaborator for scientists.
How does it ensure security and privacy?
OpenScience ensures security and privacy by keeping API keys on the user's machine and sending requests directly to the models. This means that users have control over their data and API keys, and they don't have to worry about their information being exposed.
What are the key features that make this repository stand out?
The key features that make OpenScience stand out are its ability to automate the entire research loop, its model-agnostic design, its integration with scientific databases, and its extensibility. These features make it a powerful tool for scientists and researchers who want to streamline their workflow.
What's the significance of the browser-based workspace?
The browser-based workspace is significant because it provides a user-friendly interface for scientists to interact with the workbench. It includes a file tree, an editor, a terminal, session history, and inline rendering for various scientific data types. This makes it easy to navigate and work with your research data.
How does OpenScience handle the different types of scientific research?
OpenScience is designed to handle a wide range of scientific research, including machine learning, biology, physics, and chemistry. Its bundled skills and integration with scientific databases make it a versatile tool for various research domains.
What's the role of the TypeScript SDK in the extensibility of the platform?
The TypeScript SDK plays a crucial role in the extensibility of the platform. It allows developers to build custom agents, commands, and plugins that can be integrated into the workbench. This makes it possible to extend the functionality of OpenScience to meet specific research needs.
What's the impact of this repository on the scientific community?
The impact of this repository is significant. It has the potential to revolutionize the way scientists conduct research by automating many of the tedious tasks involved in the process. It also makes scientific research more accessible and efficient, which is a huge benefit for the scientific community.
Who should actually care about this repository?
Anyone involved in scientific research, especially those who are looking for tools to automate parts of their workflow and make research more efficient. It's also of interest to developers and engineers who want to build upon an extensible platform for scientific computing.